Hello, my name's Dr. Frances Cooper and I'm a geologist in the School of Earth Sciences at the University of Bristol in the United Kingdom. My area of research really focuses on structural geology and tectonics, which basically means I try and understand how large mountains form, for example the Himalayas that are so familiar to you here in Bhutan. And so I spend a lot of time looking at the different rock types in Bhutan and also the large fault systems that run through the country and have produced the high mountains we see around us.
I'm Dr. Byron. I'm also a geologist from the University of Bristol, the School of Earth Sciences. And I'm a geomorphologist, which basically means that I'm interested in the shape of our Earth and how that is controlled by deep-seated forces from rocks pushing up, but also how it's impacted by climate, rain coming down, rivers forming, and how that can be changed by the vegetation that we see. So I've spent a lot of time in Bhutan studying how the rivers form and how they have important processes, not just for things we think about flooding, but actual importance of erosion.
So in today's program, we're going to first of all tell you about the history and origin of the Himalayas. So how the large mountains we see around us first formed from the collision between India and Asia. We're going to look at various different rock types that we find commonly in Bhutan, different parts of the country, and try and understand where they came from and why they look the way they do today.
As we have these discussions, it's important to know that some of the things that we talk about regarding the formation of mountains, they involve things like earthquakes, landslides, and floods. But these aren't things that we should all be scared about. These are natural processes that have been long-lived and are very important to the history of the Himalaya and Bhutan. And so these are things moving forward that we need to understand so that we know how these landscapes have formed, but also to better prepare for when events happen regarding earthquakes, landslides, and floods, so that we can reduce the risk that people of Bhutan have moving forward into the future.
Around 200 million years ago, the continents as we know them on the Earth today were actually joined together into a giant supercontinent that was known as Pangaea. Then around 200 million years ago, things started to change and the continents started to break apart and drift away from each other. And one of those was the subcontinent of India. And India moved northwards and closed up an ocean basin north of it that was known as the Tethys Ocean. And the Tethys Ocean was sandwiched between India to the south and Asia to the north. And eventually, India crashed into Asia, closed the Tethys Ocean basin completely, and formed the Himalayan mountains that we see today. So as India moves northwards into Asia, it slows down. So it goes from about 7 to 10 centimetres a year down to about 5 to 6 centimetres a year. But it's still moving northwards and it ploughs into Asia for about 3,000 kilometres. So it doesn't completely stop and the Himalayas keep on growing. Okay, well here we are at Drugalzong. This is a great place to look at some of the really high temperature rocks that got buried when India crashed into Asia. So let's go and see what we can find.
To align the minerals.
Yep. So these are a really good example of some of the high temperature metamorphic rocks that we find in the Himalayas here in Bhutan. And they're quite distinctive. It's a little bit hard to see in this particular outcrop because it's covered in lichen, but overall this outcrop has a strong fabric to it. It has dips in a certain direction, and that's an indication that this rock has been squashed and you've developed quite a strong fabric within that rock that formed when the Himalayas were being formed. Now, it's hard to see the rocks themselves here because they're covered up in this lichen, but we've actually got a piece of the rock here that we can show you in a little bit more detail. So you can see hopefully in the sunshine that we've got some sparkly minerals in this rock, and those are known as micas, and they really catch the light when you look at the rock. And those micas have a sort of platy shape to them, so they're very flat lying. And it's those micas that align in this, because they're so flat, that creates this strong fabric through the rock on a bigger scale. The other minerals in here, the white minerals, are going to be a mixture of quartz and another mineral called feldspar. But the other interesting mineral in this rock, and I believe Byron has another piece here that I can show you, are these big red minerals. So hopefully you can see there's some big patches of dark red mineral. And then the same on this piece here, they really stick out of the rock. And these minerals are called garnets. And garnets are very interesting minerals because they only form when a rock has got to very high temperatures and pressures. The only way it can get to high temperatures and pressures is by being buried deep down in the Earth's crust. And we can actually look at the chemistry of these minerals, these garnets, and some of the other minerals in the rock associated with the garnet. And we use different equipment in our laboratories to measure the amount of certain elements present in these minerals. And that can actually tell us how deep these rocks once were. And based on those kind of analyses that have been done on these sorts of rocks in Bhutan, we know that these rocks have been at pressures that are roughly 6,000 times higher than the typical atmospheric pressure that we feel around us from the air. And they've been up to temperatures of about 550 degrees centigrade. So these rocks have been cooked to very high temperatures, and they've been buried and squashed at very great depths in the Earth's crust. And then what makes that so interesting is that here we are finding them on the surface today. So we know that the collision of the Himalayas forced these rocks all the way down a few kilometers beneath our feet, and they've been brought all the way back up again. And one of the ways that they get brought to the surface is the surface gets eroded away by the rivers that Byron studies. And so these rocks tell quite a story of the origin of the Himalayas. So you can see here on the large-scale outcrop here beneath Drugalzong that the rock has this very strong fabric to it. And that's pervasive throughout the whole outcrop. You can really trace it if you look across the outcrop. And then you can see the same thing in the sample I'm holding in my hand, that the minerals tend to align in certain layers throughout the rock. And that's because as the rock has been squeezed together during the compressional formation of the Himalayan mountains, the minerals have realigned themselves into a certain orientation. And in particular, the flat platey micas have all aligned themselves. And so you can see it when you pick up a stone on the ground, what you can see within a single stone. So you can see here quite clearly in this outcrop here beneath Drugalzong that the rock actually has quite a strong fabric to it. It's got a layering within it. And that layering and that fabric was formed by metamorphism of these rocks. And metamorphism is basically when they've been buried deep in the crust, many kilometers beneath our feet, and cooked to high temperatures, roughly we think about 550 degrees centigrade, and high pressures, maybe up to 6,000 times atmospheric pressure. And as a result of that, certain minerals within the rock will realign themselves into a certain orientation, and that gives that pervasive fabric through the rock. And you can see that quite clearly when you look at an individual stone, if you pick it up on the ground, that certain minerals tend to align themselves in a particular orientation. And the ones that do it best are the micas, and the micas are the sparkly minerals that catch the sunlight when you move the rock around, and they have a very platy shape to them, so they tend to realign themselves. Now this particular rock here that we picked up from the floor, it's quite easy to see all the minerals, and it's been sort of washed clean almost. The outcrop here is covered in quite a bit of lichen, and you can also see it's been darkened. There's been a lot of weathering taking place, and the different layers, some are sticking out and some are not, and that depends on what kind of mineral they're made of. So the layers that tend to stick out the most have a lot of minerals such as quartz and feldspar in them, and the layers that tend to get eroded away have a lot of the mica in them because they tend to get washed away by the rainwater more easily. Well, I'm sitting here on a particularly interesting rock type here in Bhutan. We're in a valley just near the Bailandra monastery, northeast of Punakha and Wongdi. And this rock is quite unusual, maybe not what you usually see around Paro and Thimphu, and that's because it's a marble. And a marble is formed of calcium carbonate, and this rock once upon a time would have formed as a limestone in the shallow marine environment in the Tethys Ocean. And as we've already discussed, the Tethys Ocean closed up during the formation of the Himalayas as India crashed into Asia, and that ocean basin that was in between got completely squashed together and forced up to the high elevations that we see in Bhutan today. In this position here, we're sitting at an elevation of about 2,000 meters above modern day sea level, but we know that these rocks once upon a time were below the sea. So that means that they've been pushed up a really long way to where we are today. Now, one way we can prove that this is a marble and is made of calcium carbonate is by using a little drop of hydrochloric acid, and I have very dilute hydrochloric acid in this bottle. So I'm just going to pour a little bit of this acid onto a patch of the marble here that's been hit by a hammer, so it's a nice fresh surface. So if I drip a little bit of hydrochloric acid on, hopefully you can see that it really fizzes. That only happens on this rock type, so you wouldn't get that on a quartzite or a granite. And the reason is that the hydrochloric acid reacts with the calcium carbonate to form carbon dioxide gas, and that makes it fizz, and so you get this fizzing bubbles on the surface. The other interesting thing about this particular rock here that demonstrates the incredible forces that pushed together to form the Himalayas are the fact that you can see these fold structures in this rock. Can you see how it sort of looks a bit swirly? It's not very linear fabric here like we've seen in some other rocks. And these beautiful fold structures are formed because this rock has been pushed and squished together during the formation of the Himalayas. And as it was pushed together and forced all the way up to 2,000 meters in elevation, you folded it and formed these pretty amazing deformation structures. So this rock records a pretty amazing history all the way from beneath the sea all the way up to the high elevations in the Himalayas today.
So we're here at the museum near Tazong, and what we're looking at is a 3D representation of Bhutan. And there are some interesting things that I want to point out. One is that if we look at Bhutan from south to north, we find that Bhutan starts at very low elevations in the Indo-Gangetic plains and then rises up to very high elevations near 5,000 meters in the Tibetan Plateau. And what we also know is that because of the faults that exist at the base of the Himalaya, at the very southern portions of Bhutan near Phuntsling, Gelugpa, Sarpang, Samdrujonka, that's where we actually find very high rock uplift rates, where the faults are active today. But there's an interesting thing because there's also a lot of precipitation right at the front of the mountains. Because of the moisture that comes up from the Bay of Bengal during the South Asian monsoon, that rams right into the front of the very steep Bhutanese Himalaya. And when that happens, that moisture falls down to the earth in the form of precipitation. And so not only do we have very high fault activity rock uplift rates at the southern portions of Bhutan, but we also have significant rainfall. And so that's sort of what creates this topography where we find sort of lower elevations going up to very high elevations. And the interesting thing is at these high elevations, we finally have temperatures cold enough to sustain significant glaciers throughout the Bhutanese Himalaya. Some exist today, but they're shrinking at a rapid pace because the globe is getting hotter as a function of time. There are a few sets of really high peaks in Bhutan. There's the set of high peaks that runs along the northern border that you may have seen a lot of if you've been to somewhere like Dochula. Some of these peaks include Jomalari, Kangbam, Gangarpunsam, and those peaks are right at the edge with Tibet. But there's also another set of high peaks that some of you may have seen that include places like the Black Mountains. The interesting thing about the Black Mountains is that on top of the Black Mountains we find limestone deposits. So these are rocks that were once in shallow ocean that contain fossils. And so basically these rocks have been uplifted several thousand meters over the evolution of Bhutan. The reason why we think these peaks are so high sort of in the central parts of Bhutan is because the rocks have been pushing up very hard in these regions, similar to the way that the rocks have pushed up very quickly along the southern borders of Bhutan. The interesting thing is that right at this position in Bhutan, we also find that there is a significant change in the rivers. The rivers, the Paro-chu and the Timpo-chu, become much steeper when they converge at Chuzom and then flow downstream to places like Chuka. And so the reason why those rivers are steepening is because they have much more energy because the rocks are pushing up much faster in those places. And so it's at these positions in Paro and the Paro and Timpu-chus where we actually find more sediments, more cobbles, flatter valleys where people are able to have farms and build houses. And that's because the rivers have less energy to move all of the sediments out of the landscape. So another important thing to remember when we're considering these landscapes is that over the course of the 50 million year history of the Himalaya, there have been several important faults that have been active. And faults are anywhere where we find rocks moving against each other. And these are important because these are how we build mountains. We move rocks up on top of each other, and if we move more rocks on top of each other, we actually make a stack, much like you'd stack books. And so what we're doing to build up these mountains is we're stacking rocks. And so there are a few important faults running from along east to west along Bhutan. Over time, some of these faults have been active and sometimes they haven't been active. But at the very front of Bhutan, very far in the south, that's where we think some of the most active faults are in Bhutan. And they sort of dip in like this. So you can imagine that there's a series of faults that over time have become more active towards the south. And that's how we have stacked up the rocks high enough to form a mountain range like the Himalaya. So some of you may actually have some experience with these faults. But basically, when these faults slip past each other, they can create a lot of energy. And that energy we feel as an earthquake. So earthquakes are actually natural processes that tell us that these rocks are moving past each other. And there have been a few recent examples that you may be familiar with from the Nepal earthquake in 2015, but also the Sikkim earthquake that some of you in western Bhutan may have felt in 2011, and even the 2009 earthquake which occurred here in Mongar. So every time that these rocks are moving past each other, we have an earthquake.
Hello. In addition to faults which build the mountains in Bhutan, rivers are also very important. What would the Bhutanese Himalaya be without the beautiful valleys that everyone lives in? There are many different types of valleys in Bhutan, and those different types of valleys, whether they're very deep or very smooth, are formed by the rivers throughout the country. While rivers coming together are very important places in Bhutanese culture, they're also very important to geologists in studying the ways that the Himalaya have formed and will continue to grow. We're here at a special place, Chuzom, where the Paro-chu and the Timpo-chu come together to form the mighty Wang-chu. And what we can see here within the rivers there's a lot of activity. We see waves forming, we see large boulders, and we see that the river is carrying a lot of large rocks and cobbles. What we'll see if we go upstream of Chuzom, if we go up the Timpu-chu or the Paro-chu, we see that the river changes. One of the reasons why these rivers change is because of the faults which are pushing rocks up toward the surface. And the reason why this is important is because these rivers are working to what we call erode, where they pull the rocks down from up high and transport them downstream. And these rivers are, in most places, eroding at the same rate that rocks are pushing up. And this is an important process throughout the Himalaya, especially in Bhutan, because there's a balance, and this balance stabilizes the landscape. What we'll see when we go upstream is that the river response is different because we have different upward forces within the rocks based on the way that the faults are moving. In addition to tectonics, which is a broad term which describes how faults move, rivers are very important. To prove this, I'd like you to think through something with me. Let's say that the faults that form the Himalaya have moved for 50 million years, and they move at a very fast rate, and they'll continue to move. That would mean that our mountains will continue to grow until those faults stop. But that's generally not what we see in these landscapes. What we find is that there's somewhat of a balance, and that balance of our upward forces are provided by these rivers. These rivers are actually eroding down into the rocks. And so as we have faults push the rocks up, we have rivers which cut down into them. And when the rivers cut down into these rocks, we see the valleys that found throughout Bhutan. And there are many different types of valleys throughout Bhutan. We're here in Chuzom, where the Thimphu Chu and the Paro Chu come together to form the Wang Chu. If we think of the valleys that lie upstream, so up these rivers, we find very smooth valleys where you'll find the cities of Thimphu and Paro. These are important. It's important to have these smooth valleys because they're good places to build houses, to grow crops. But if we go downstream on the Wang Chu, what we find are very steep, very narrow valleys. People can also live here, but it's not as easy. And when we look at what the river is actually doing, we get a sense for why the river and these valleys may be changing. So here, again, we're at Chuzom, and we can see that there are waves in the river. There's a lot of energy here. And we see that there are large boulders that this river is moving around. And so there's a lot of energy to actually erode very deep and narrow canyons. And so it changes the way that the landscape looks dramatically. But if we go upstream, we find very different types of sediment. And sediment are just bits of rock that we see the river carrying. This could be large boulders to small grains of sand. And when we go upstream into Paro and Thimphu valleys, we see that the river has been depositing a lot of these sediments for a long time, as opposed to moving them through the valley like we see downstream. This is caused by a difference in what the faults are doing down deep. And so there's less energy for those rivers upstream because there are slower faults in those positions, slower uplift of rocks. And so the rivers don't have as much energy to move the sediment downstream. This is important for the history of Bhutan, the agriculture, and the way that people will continue to live in these landscapes. And it's all balanced by what the rivers are doing throughout the country. Let's look at what the rivers are actually carrying here, because this can tell us a lot about the energy of the river. What are they able to move? You can see that there are very different size bits of rock around. But one of the things that we look for when we look at the stones that rivers carry is that you can see that a lot of them are very round. And we would call this a river cobble. And river cobbles tell us a lot about the way that rocks are bashed around. They hit against other rocks as they travel downstream, and they eventually get very smooth over time. We can also look at the types of rocks that rivers are carrying. This gives us a good idea about the rocks that are being eroded upstream or where we are right now. You can see, though, that some rocks have been transported differently or break apart differently. Some rocks break apart in angular fashion, so we have flat sides and we have corners, but others get very rounded. But we generally like to think that the roundness of a cobble tells us something about how far it's moved, or we'd say how far it's transported. The interesting thing about the Thimphu and Paro regions is that you can actually see cobbles like this way up high, much higher than the water is today. In fact, there's a really great place to see this. Just about 2 kilometers toward Thimphu from Chuzom, you can see that a lot of these rocks, as well as some of the sand, is actually in where the road has been cut into. And that's great. That tells us something about where the river used to be at an older time. So we could imagine that the Thimphu Chu and the Paro Chu were actually up higher at a different point in the history of these rivers, and now they've cut down to where they are today. And these rivers will continue to do that in order to balance the rock uplift, the tectonic forces that are happening in Bhutan today. And this gives us a sense that this is a living, dynamic system. Hello, again, we're here looking down at the Paro Chu. And what I'd like to draw your attention to is how different this part of the river looks as compared to what it looked like downstream at Chuzom. And what we can see is that the Paro Chu meanders, or it curves, down a very wide, flat valley with fairly gentle sloping hill slopes around it. And the important thing here is what the rivers are doing. I'll remind you that this was a cobble that we looked at Chuzom, and what we can see down there in the valley, within the river channel, we can see the same cobbles. And so this river is actually carrying cobbles like this, but it's not doing it as efficiently because the river has less energy. And so instead of just carrying all of the sediment out and down the river to Chuzom, down to the base of the Himalaya, to the Bay of Bengal, what's happening is that the cobbles are getting stuck here. And it's because there's not as much force, force pushing up through tectonics with the active faults in this region.
Well, here I am sitting just below the Golden Buddha in Thimphu, and this is a really great place to see the proximity between where a lot of people in Bhutan live and the mountains that surround us. So mountains, as you know, are very pervasive through Bhutan, and a lot of the cities and the villages across the country sit right on the sides of these big mountains. And as we've discussed, these mountains have formed over many millions of years since India first crashed into Asia about 50 million years ago. And it's important to remember that that process is still going on today. So those mountains haven't stopped growing. They're still being uplifted as we speak. And the way that they're being uplifted is by movement of those big faults that we've already talked about. And every time one of those faults moves, we get an earthquake. And those earthquakes can happen throughout Bhutan. And as has been demonstrated over the last few years, they can happen in neighboring countries, such as in Sikkim and in Nepal. But the destructive power of those earthquakes is also what forms these beautiful landscapes and is the reason that Bhutan is so beautiful and that we have these mountains here today.
When we look out to a valley like the Thimphu Valley here, it can often be difficult to remember that we're right next to a river. So within all of our city scenes here, we can find the major rivers that are help forming these broad, flat valleys that we see.
So not only are these rivers vital sources of water for our drinking and for our agriculture, and so we need to protect them and keep them clean. But also these rivers have become a major process for creating the landscapes that are important to us. It's very important for places like Bhutan to have flat places to build homes, to have rich soils to grow crops in. But over long periods of time, even before humans settled in Bhutan, rivers were important here because they've helped form the topography, they've helped shape the landscape, and they've helped create the diverse valleys that we see. In some cases, we get very steep and deep valleys, which we see along the southern portions of Bhutan, maybe in places like Chuka. But we also see the flat valleys like in Paro, Thimphu, and Bumthang. And so these rivers have created these different valleys because they have different energy. They have different ability to cut down into rock and to move sediment through the valleys. And so that energy is actually provided by the forces pushing up on the rocks and the faults that are helping those forces move rocks towards the surface. And so it's all part of the same cycle that has helped build the Bhutanese Himalaya. Moving forward, looking to the future, these rivers get bigger when we have more precipitation during the monsoon, for instance. And so when the rivers get bigger, there's more water, we can have flooding events. These flooding events are important for enriching the soils around these big river valleys, and so they're an important natural process. But now that people live here, we also have to be careful and be thoughtful about how we build villages in the future and building strong communities so that when we do have flooding events, we can come together and make sure that the society is good and that people can continue to live in these valleys.
Well, we hope you've enjoyed learning about the geology and the landscapes of Bhutan that surround you, and we just would like to say, Tashi Deli.